Okay, so hello everyone. I'm Olivia. I'm the person who's running this course, and this is the first uh, lesson plan for the Python course. The recording for the original lecture, I guess, uh, crashed and is not there. So that's why I'm recording this now. Okay, so to begin, we've got, in case anyone wants extra references or extra materials for learning Python, here are some good resources. That's that section. And this overall course was pretty much a very condensed version of this first book of learning Python programming. And basically, all of these books that you've got here are really good comprehensive resources for learning Python. They're much less, at least this one is much less beginner friendly, but it's still very useful. So I recommend those in case anyone wants to do even extra Python work, and then getting into the actual course. So lecture one is going to be about how to install Python and some of the basic features that you're probably going to need to know. This is basically a hub of all of the example codes that I'm going to be using. So, like today, I'm going to be using these in order to demonstrate the concepts that I'm going to be talking about. Uh, but yeah, that's it. And then this is when we get into the installation and taste of Python part. So if you don't have Python installed, you want to install, we're going to be installing Python 3.9. Although the latest available is already in the 3.10s, it's not really necessary to always have the latest version of Python at all times. And so 3.9 is still very commonly used, so that's why we're using it. I use a Windows computer, so the way this is gonna look to me is gonna be different than if you're using a Mac. But what you want to do is go to this link, click on the link, and then scroll all the way to the bottom where you're gonna see this little table of files. And if you're using a Mac, you want to use click on the highlighted link that says Mac OS for the operating system, and then click on the highlighted link for the one that says Windows if you are using a Windows computer. So once you click on that, can open it. I already have Python installed actually, so that's the whole thing isn't gonna really work. Walking through the whole thing isn't really gonna work for me, but basically you don't really need to do any extra fiddling with any of the settings that are gonna come up. You can just leave them as the default for all of them. Once you've got Python installed, you can see that you've got the Python interactive shell here, where you can insert a bit of Python code and it'll run Python. But of course, it's kind of hard to do like full-blown projects in this little console, which is why we are going to be downloading an extra integrated development environment, which is basically just a way to make coding much easier by integrating things together in order to develop more easily. And so the one that we're going to be using is called PyCharm because it is like free, open source, and pretty powerful. And so what you want to do for this one is click download on the one that is free, and not professional, but the community one. And again, I have this downloaded, so it's not really can't really show you every step of the downloading process. But again, all you really have to do is leave everything as the default. You don't have to fiddle with any of the little options that come up when you are going through all the panels that the computer is going to show you. So once you have that downloaded, you're going to want to open PyCharm. So let's open it here. And you want to create a new project. So I already have some projects here, but if I were to create a new one, um, the location, you can just leave it as default for now, I believe. Yeah, okay. So for the location, you can leave it as default. You want to make sure your virtual environment is set to new virtual environment using virtual NV, which I believe should be the default. Um, Everything else, you want to make sure these are unchecked, which is again the default. And yeah, essentially, so this you can name whatever you want, really. But the everything else, I think you should leave like this. So, and I can just say leave Python project is fine. Uh, there's some extra information on the document about what a virtual environment does, but it's generally not necessary to know for now. So while this is creating, um, let's go back to here. Yeah. So, um, okay, well, I actually can't do anything while it's creating, but wow, it's created now. So once that's done, you want to make sure you're not messing with anything in the venv folder here because that's the virtual environment. And you're going to be messing with it a lot later, but not now. So next, what you want to do is right click on your new project and hover over new and create a new directory. And you want to name this directory SRC, which stands for source. And this is where all of your Python files are going to go, essentially, and where all of your programming files, because it's not always just Python. Although for this class, it probably is. Um, and there you go. You have just set up, your Python interface that you're going to be working with for the rest of the sessions. So usually, I guess it's tradition. I never really learned why. But the first thing you want to do when you learn a new programming language is to print or display the text "Hello World." And in Python, this is actually extremely easy. It only requires one line of code. There you go. You've done all you needed to do in order to display "Hello World." So in order to run a Python file, you want to right click in the little text section right here, and then click Run for the file name. And it's gonna pop up in this little box at the bottom in the Run tab. There's a few other tabs in this box: problems, terminal, Python packages. But the only one you really need to know right now is the Python console, which is pretty much the same as the console that you uh, saw earlier over here, where it was like a bit more confusing and less sleek than this version of Python. So like basically it'll automatically execute everything that you put here, while in the file you have to tell it to execute everything. That's the main difference between the two. Okay, so once you've displayed "Hello World," you can continue on to everything else. And what everything else includes is objects. So in Python, like in most languages, you are going to be dealing with objects. uh, and three of the most common objects are going to be numbers, numbers, strings, and lists. And that's what we're going to be spending most of our time going over right now. So if I were to open old projects, okay, having a little bit of trouble finding where my other projects went. Okay, here we go. Yeah, that's Hello World. Here we go. This is all the examples I had. These are all the examples I have for learning numbers in Python. So Python, first and foremost, has a bunch of built-in calculator features. So you can use Python as a calculator if you really wanted to, although it would be rather, I guess, bulky for a calculator. So you can add, you can subtract, you can divide, and you can multiply. You know, a full range of mathematic capabilities. Now, you might have noticed that only one of these had any decimals, and that is the one that divides. And that is because there are two main types of numbers in Python. The first one is int or integers, and these do not have any decimals, while the second one is float, or floats, and these do have decimals. So when you type a number, like let's say this, with no decimal points, Python is automatically going to see that as an integer. But the moment you add some decimal points, Python is going to classify that as a float. So if you were to add an integer with another integer, or multiply or subtract, Python's going to see the result as an integer as well. But if you divide two integers, Python is going to see the result as a float. Even if the answer could be written as an integer. And so some other mathematical functions that Python will have will be the floor function, which is basically, rounding down. So if I had, 7 divided by 2 is equal to 3.5, 7 floor 2 is equal to 3. So even though normally you would round up in this situation, the floor function just basically truncates the numbers on the end of a float. Then you've got mod, so which is the percentage sign, and it just tells you the remainder of that number mod, of the first number mod the second. The remainder of the first number divided by the second number. So 17 divided by 3 is equal to 5.6667, right? But if you did that, if you wanted to do 17 divided by 3 with remainders, but then only wanted to know the remainders, then you would do 17 mod 3. You can also do exponents with Python. So 5 squared would be 5 double star 2, 5, and then 5 cubed would be 5 double star 3. And then, you've also got parentheses, and the Python also obeys PEMDAS, just like any calculator would. Okay, that one was probably the shortest out of the 3 main objects. I just closed the wrong one. And next we have strings. So what is the deal with strings? Well, strings are not like numbers in the fact that they are text. They're text to be displayed, pretty much. And you can put pretty much anything. A string is determined by its quotes. So if you put quotes or apostrophes around something, or single quotes around something, that makes it a string. If you put double quotes around something, that also makes it a string. And then if you put triple quotes using either quotes or apostrophes, that will also be a string. Strings usually in Python, from what in my experience, Python like integrated development environments will color certain Python objects to make the code more easily readable, and strings are usually colored green. So um, in some cases, you'll want to type a string or you'll want to type some text that actually has an apostrophe inside of it, but you don't actually want the text to end there. So in this case, you'd want to use some special signifiers, such as this little slash that tells the code essentially to ignore the apostrophe that comes after it. So if I try to print, it's no use. That Python would give me an error because it's invalid syntax. I did not format it correctly. And you can see here that only some of it is in green, which means only some of it actually counts as a string because of the way that I put my quotation marks. And so instead, what you want to do is you want to either switch up, you want to either use the slash to tell Python to pay no attention to that quotation, to that apostrophe in the middle. See, that works perfectly. Or you want to switch up your quotation marks so that you're using double quotes in the outside and single quotes in the inside. I mean, these slashes also apply to double quotes, of course, and the switching it up also applies to using single quotes on the outside and double quotes on the inside. If you wanted to print something on multiple lines, then there are quite a few ways to do that. The first is to use a slash again, but this time do a slash n, so it looks something like first line. Or you can use triple quotes, which you saw in the very beginning of this file, which looks something like first line. It doesn't work as, not quite sure how I can get it to work in here. Yeah, okay. Can't really get it to work in the console right now, but you'll see it later in this file. So either way, you'll come across it. What's interesting about strings is that you can make them interact with numbers. So if I wanted to repeat a string many times, I can just multiply it by an integer. So if I wanted to really annoy someone and say their name a bunch of times, like hey Callie, 15 times, then I can just do something as simple as that. And of course, commutative property does apply here. You can do the opposite way around and have the number come first. This is important because there actually are a lot of cases in Python where the order matters a lot, where there will be some cases where something won't come first. Okay, I don't know why this isn't running. But it should work. So, oh, okay, there we go. And one of the most common features of a string that you'll probably be using is its concatenation abilities, which it just means like its ability to join. So just putting two strings next to one another will join them together. So A. But I prefer to do this latter one. You can also join two strings together by putting a plus sign in between them. I like the latter one just because it's a bit clear to the eyes, but the first one is probably more efficient. Okay, so after that, yeah. So here's an example of using triple quotes to print multiple lines of code. Just like how the /n thing will print multiple lines of code. Okay, and one important thing in Python that works for both strings and lists will be indexing. And so indexing is just a way to mark the positions of values in a set of values, essentially. In this case, for strings, the value will be a letter, while the set of values will be all of the text. So if I wanted to take out a set of letters from a word or from a sentence, then I will be using indexing for indexing code, I suppose. So let's say I had my word and it is equal to, oh, wait, my word is going to be heliophobia. I think that's a word. No, I don't know that word very well. Acrophobia. There we go. And let's say I wanted to only take the very first letter of this word. If I wanted to do that, then what I'd have to know is which letter, how to refer to the first letter of the word. And so the way that that works is that you need to, in this case, we're using variables, which you have not learned about yet, but you'd want to take your word and then put brackets right next to it. And then inside the bracket, you want to write the position of the letter that you're referring to. The 0th letter, so Python uses a counting system where the 0th letter is actually the first letter. So when I say word bracket 0 or acrophobia bracket 0, I'm really talking about the first letter of acrophobia, which is A. So if I were to print this, I should get A. And indeed I do. Now, Python also has an ability where you can refer to positions of values negatively, which at first might not really make sense, but the way it works is that the first letter is going to be the 0th letter, and then you want to go backwards. So the last letter is going to be letter -1, and the second to last will be letter -2, and etc. So the letter -2 of acrophobia would be I, and so I get I. Now, it would not be interesting if you could only select particular letters of a word. You can instead use slicing, which is very similar to indexing, but basically will select multiple values to select parts of words. So if I wanted to only print the acro of acrophobia, I would say print acrophobia bracket 0 to 0 to 4. So what 0 is the 0th or the first letter of acrophobia, while 4 would be the 4th or the 5th letter of 4th in Python terms, and then 5th in normal counting terms, letter of acrophobia. Now, the reason why I'm referring to the 5th letter of acrophobia is because the second letter in your slice is going to be excluded. So you really want to add you want to add an additional 1 to your second letter in order to get what you want. And there you go. The P is not included, even though that one is the fifth letter. If I wanted to make this a little bit more efficient, I could. Oh, I misspelled acrophobia twice. Okay. If I wanted to make this a little bit more efficient, I could eliminate the 0 from the slice altogether and just say :4. And it will assume that I'm talking about 0 in the beginning at this as the starting point of my slice. If I wanted to change the starting point of my slice, I can just change it by putting a different number there. The first number is inclusive, so you see included, and so it will start from the second or third letter, which in this case would be R, and then end at the end before the fifth. So that would be O. So yeah, it prints RO. And then just like how you can eliminate the first letter from a slice, you can also eliminate the second letter from a slice. And just leave it blank, and it will assume that you are simply referring to the entire rest of the string. There you go. Let's see. You've also got the ability to use negative words, negative positions in terms of slices. In this case, you'd be talking about the letter from the second, starting from the second last all the way to the end, which would just be taking the last two letters. This shows how you can how these things can be manipulated with concatenation or joined together with concatenation to create new strings. So if I wanted to say acroia or acria, I could take acrophobia, 4 plus acrophobia 2, and I would get acroia. I don't know if that's a word. I'm pretty sure it's not, but you can do that in Python. Okay. Of course, you cannot use slicing or indexing to refer to a number that is a position that is outside of the values or outside of the set of values, or in this case, the word length. So acrophobia only has so many letters. I cannot refer to the 5,731st letter as it is out of range. Okay, and one last thing about strings is that they are immutable, as in they are unchangeable. One thing that you'll find about lists, which are coming up, is that they are mutable. So this is a bit more easily understandable once you get there, but once you've set a string, essentially, you can't swap around parts of it. You can't refer to a letter in the string and say, I want to change this letter. You have to create a new string for that. Yeah, so if you try, it'll say that string object does not support item assignment. Now, something that does support item assignment is lists. And so a list is essentially a set of values where the set of values is more obviously a list. I mean, yeah, a list is a list, essentially, of values that is defined as a bracket of things enclosed in commas. So that right there is a list. Lists can also have, lists can be empty where it's just the bracket. Lists can have strings inside of them, string 2. You can also have a mix of things. There's my list. Um, and yeah, so let's say, um, okay, lists will be using variables some more. So I'm just going to cover that first before we get into lists, actually. So what a variable is it's basically a named location used to store data in the memory. Um, it's essentially like a container that will hold things that can be referred to later in your code. So if I had number is equal to 10, then I can print number instead of saying print 10. And it'll understand that number is equal to 10, so it'll just swap out number for 10 when it's running this code. So I can say number plus number, and it'll interpret that as 10 plus 10. Or maybe, you know, uh, so it's essentially treating the word number as 10 every time that I include it in my code. And that's, I mean, yeah, that's that's what variables do. The names that variables are stored under are called identifiers. Identifiers are also, names given for other things, but uh, we're not talking about those other things right now. So right now, they're just names given to variables. There are a few rules regarding what you can use as an identifier or as a name. Essentially, you can't start them as numbers. So while I can say like uh, trait one is equal to like jealous, I can't say one trait is equal to jealous, or it'll give me an error. There's certain words that you can't use a as an identifier, such as global, because these words already mean other things inside of Python's code. So I can't say global equals, or else it'll give me an error. And then there are also some special symbols that are prohibited from being used as. Um, okay. Okay, I don't know what's up with that. Um, but either way, you can't use that as an identifier for a variable. So now that we know what a variable is, uh, you can't really use lists very often without you having variables. So let's define our first list here. Squares is equal to 1, 2, that's not a square, 4, 9, 16, 25. There we go. There's our error. Something you might have noticed has been this little panel over here. It's very useful because it'll tell you basically all of the variables that you've got and tell you what they're at all times so you don't lose track. Um, yeah, there you go. It'll even tell you specific aspects of your variables if you want to. Um, so here we've got squares is equal to 1, 4, 9, 16, 25. And just like strings, lists will have indexing. So you can refer to certain positions, certain values in your set of values through their positions. Um, so if I wanted to pull out the first square, I would say print squares, uh, bracket 0, as in I want the 0th square, which is the same as the first square. Again, negative numbers will work as in like a counting backwards function. So if I wanted squares -1, that would give me 25, because if I were to count backwards starting from 1, that would be the first one I'd come across. And then just like strings, you've got slicing as well. Um, unlike how a string, no, kind of like how a string will put together, will take out parts of a word or a sentence, slicing a list will take out part of a list and make it a new list. So if I only wanted the first three squares, that's four. Okay. The Python counting system still confuses me every once in a while. If I wanted only the first three squares, then I would slice and up until the third, which up until the fourth square, which is excluded. As you can see, it will make a new list. It won't like edit the original one, because you can see here that the original variable squares still has all five squares in them. Um, okay, you can also concatenate two squares together. Sorry, not squares. Two lists get together, just like how you can concatenate two strings together. So if I wanted to say squares plus, what are some more squares? 25, 36, 49, and 64. Then I've got a new list that has been joined together, that has been made after two older lists joined together. And, that's pretty much exactly how strings work as well. But unlike strings, everything so far has been very similar to strings. This one is not, in a way, because it is mutable, as in you can change these things after you have already created them. Remember, if you tried swapping out a letter in a string, it'll tell you error, that won't work, essentially. But for lists, it will not give you that error. So let's say I defined squares wrongly, or let's use a new list. Cubes is equal to 1, 8, 27, 65, 125. Oh my god, I just defined this list wrong. I need to change it. Well, if this were a string, I just have to make a new string. But this is not a string, this is a list, which means I can change it. So the way that works is very similar to defining a variable. You just give the name, and then you give uh, the position of the value that you want to change, which in this case, it's the one that's not a cube. So that would be 0, 1, 2, 3 is equal to 64, which is a cube. If you wanted to show cubes again, it has muted, it has changed, so that the fourth value is now a 64. You can change them in other ways where you can add on to them. So cubes that append would be append 216, and then cubes again. You can see that 216 has been added on to the very end. Append will always add things on to the very end. It's not going to like put them anywhere else. And that's why it's called append, because it's kind of like you're appending things after everything else is already done. And if you wanted to, you can replace the number with a little expression. A Python will calculate it and then append it. That works too. You can also remove parts of these using slice. You remove parts of lists using slicing. I mean, you can see here. I'm just going to do it with the cubes, but if I said cubes of 2 to 4 is actually now blank, show cubes, you can see that the third to the third to fourth cubes have been taken out and replaced with blankness, as in they are no longer there. Um, what's after that? You can also clear the list by replacing all the elements with an empty list. Oh, something I forgot to mention is that slicing and just only using the colon is just going to include every variable under there. So just like how starting with a number and not including the second number, Python will assume you mean like the last letter, or not starting with a number and just including the last number. Python will assume you mean the first letter for this one. Not including either will mean that Python assumes you mean the first letter and then the last letter. So there you go. That's just all of cubes, while assigning value would affect all of cubes. So now cubes is just an empty list. Okay. One very useful function that you will be coming across when it comes to lists is the length function, which is a function that tells you the length of the list, which is essentially just the number of values that you've gotten there. So while cubes at this point would have had a len of, if I ran len at that point, it would have had a length of 4. It now has a length of 0 because it's got nothing. Um, there's proof. Nested lists. Yeah, you can have lists inside of lists, just like how you can have strings inside of lists and have numbers inside of lists. If you wanted to refer to a list inside of a list, so x is equal to 1, 2, or 2, 3, 1, third, cat, and I wanted to refer to 3, I'd have to first identify the position of the list that I'm looking at, which would be the first list, and then identify the position of the number that I'm looking at inside of the list, which would be the second number. And it'll give me 3. Now, if I just want to look at the first list, it will give me the whole list. And yeah, that's nested lists. This length function will also work on strings. Forgot to mention. I have it. What? Oh, I have it defined earlier that trait 1 is equal to the string jealous. So if I wanted to find out how many letters were in the string jealous, I could run the length function, and it'll tell me it's got 7 letters. Now for the last part, I've already gone over identifiers and variables, but we've also got comments, which you will also see very commonly. Comments are defined by the presence of a hashtag or a pound sign or a number sign or whatever you want to call it at the beginning or at any point in the line, really. Anything that comes after a number symbol, I'm just going to call it a comment sign from now on, is going to be part of the comment. And what the symbol tells Python is that everything that comes after it can be ignored. So you can really type anything you want here, like global. Like remember from before, global can't be used as a variable name or an identifier, but it can be typed here because you can type anything here. These are just used to comment on your code or discuss your code to whoever's reading or anything along those lines. Python is also a case-sensitive language, so when you're creating identifiers, you want to make sure that you are keeping your capitalization consistent. So if I had 2 variables, yonder is equal to 1, yonder is equal to 3, those are 2 completely different variables due to the different capitalization. Now, this also applies for functions. If I wanted to print yonder, I cannot spell print with a capital P because it will not recognize it. So generally, almost everything in Python is going to be lowercase for like these functions and the like. Then you've got statements. So one statement is usually one line of code. It is essentially one instruction that a Python interpreter can execute. So even if it's not displaying something like how print is or how length len is, it can still count as a statement. So in this example, a equals 1 is a statement because it's something that Python can execute. Um, Now, I said usually earlier about the lines is because you can have multiple line statements and you can have more than one statement in a line. An example of the former would be this here, which uses the slashes to create a multi-line statement. There you go. Well, this would be an example of multiple statements in a line. The first one has three statements because it's defining three different variables. So Python would be executing three different things, while the second has one statement because it's just displaying something. Um, okay, I don't think I really need to talk about that right now. And then indentation. This is going to be more. What's the word? Prescient, I guess. I think next session or lesson 2 when we talk about loops and conditionals. But what tabs, what identi, why? Whoa, my God, I can't speak. What indentation does is define what parts of a code belong to what parts. So since a equals 0 is put all the way to the left, that means it's isolated from this while loop. Everything that is indented under this while loop is not isolated from this while loop. It is, in fact, a part of it. So, and then this stuff, which is extra indented under this if statement, is a part of both the while and the if because it is indented. Oh my, indented under both of them. Now, this print is not indented under this if, as it's on the same level of indentation, but it is indented under the while. So it belongs to the while, but not to the if. Okay, and that's everything for lesson 1. Have a nice day, and see you later for lesson 2, which will be covering the order of the flow of Python, essentially, through different ways.